Welcome back, ladies and gentlemen. We are to our last lesson on chapter 23. It's on triangle midsegments, and I think it's actually in some ways the easiest lesson in the mix. My objective for you is that you can use deductive reasoning based on the properties of triangle midsegments, which I'm going to tell you about in a second, to make conclusions about segment lengths and also angles. So first, a definition: the midsegment, as really like it sounds, is the line segment that connects the midpoints of two sides of a triangle. It has properties. I'm going to show you a triangle here with a couple of midsegments drawn in. The properties are that the midsegment is parallel to the third side of the triangle. I'm going to highlight that. The midsegment is parallel to the third side of the triangle. And the triangle here is the side of the triangle that the midsegment doesn't touch. And the midsegment is exactly half the length of the third side, which is somewhat intuitive, but we now have that as something that we can fall back on in making deductions. Okay, so I can choose this color here. We have a triangle that I've given you. We have midsegment MN, midsegment NO. And I want to start out with this question. What is the length of segment BC? I should say segment here. I don't have a little segment symbol, so we'll put the segment symbol on top of BC. I'm going to kind of draw it in here. Here's BC. Yeah. So you might want to notice here that, well, we don't, we can actually tell from the graph, right? BC is going to be 6. Yeah. But say we didn't have graph paper and we just had this drawing, okay? We do have, given that we have midsegment MN, which is 3 units. And because the midsegment is exactly half the length of the third side, we can say that BC is going to be 6 units. So I'm just going to write that in there. Kind of in small lettering, I think. Since BC is 1/2 of MN, the measure of segment BC is going to be 6 units. Okay. Easy so far, I hope. This is 6. Yeah. All right, so I'm going to go back to red. We have here another question about this angle NOC. And sometimes students struggle to see angles, so I'm going to make sure that everybody sees the angle. It's the angle that goes, that's defined here by these two segments. Here's our angle NOC. Yeah, and you might want to stop the video for a second and think about that. Like, what is the measure of that angle? And how do you know for sure? Like a strong guess is that it's 110, which is the answer, but here's why. We need to use this property. The midsegment is parallel to the third side of the triangle, right? So in other words, this line that I'm kind of expanding off, and this business, by the way, of expanding lines and triangles is really helpful in geometry. Kind of increasing the picture, basically, like looking outward at the picture. And then I'm going to actually continue this line here too. See this segment, this midsegment NO. We have that, yeah. But that has a slope. We're going to go up to here, maybe, and down to here. Yeah. So if you can see that situation, we have this line defined by NO. We've extended out segment BC, so now it's a line. We've extended out segment MN, so now that's a line. And we know from knowing about the properties of midsegments that this line defined by MN and this line defined by BC are parallel. They're cut by this transversal NO, which means, in other words, that this angle we're looking for here is alternate interior angles with this one here that's marked as 110. So you would say, we know that by the AIA theorem, alternate interior angles theorem, sorry for my bad handwriting here, the measure of angle knock in OC equals 110. Whoops, 110. Now, here's the question. How long is mid-segment in O? I threw that in there as a bonus here, but I just thought since this is our last video for the term, it'd be good to kind of go back to the Pythagorean theorem, our old friend, and just take a look here. So use a different color. Here we have in O, yeah, and you might see, I'll use black here, that if we drop a right triangle kind of going down, I'll use black, there we go, a right triangle going down here and across here. This is a right angle, and we would say a squared plus b squared equals c squared, and that's 3 squared plus 1 squared equals c squared. 9 plus 1 equals c squared. C squared equals 10, and C, go back to red here, is actually segment in O, right? So in O, it's going to equal the square root of 10. A little better radical sign there. And there, ladies and gentlemen, we have it. We have answers to all 3 questions, and we have applied the properties of mid-segments. Have fun with this lesson, and I appreciate your efforts with triangles.